Good morning to everyone. Myself Bindu. I am from CSE section. Today I want to tell about the synchronous up counter of 3-bit and 2-bit. We want to see about the introduction of the synchronous up counters. Synchronous up counter are digital circuits that can count and the upward sequence. It can count as a upward sequence, upward to downward, and they operate the basic clock signals where all the flip-flops are trigrated simultaneously. These counters are essential in digital applications like timer, frequency counters, and digital locks. Basic of counting. The counting is a fundamental operation of a digital electronics. A counter increments its value and responsible of a clock pulse. The counting of a sequence can be as a binary or decimal or any other basic depending on the design. It can be as a counting in a sequence of binary numbers or decimal numbers of any depending upon its design, as we see in this figure. Beside of this figure, understanding the 2-bit synchronous up counter. A 2-bit synchronous up counter can count from the 0 to 3 of a binary 00 to 11. It consists of two flip-flops, as we see in the figure. Two flip-flops is considered for JK or D flip-flop, configured and operated in a synchronous. The output of a counter reflects the current count state through the combination of flip-flops. This output can reflected as the current of a count state through the combination of flip-flops. We want to see here 2-bit up counter. Truth table 0, 1, 2, 3 clock pulse and A and B. If A is 0 and here B is 0. So 0 1 1 0 1 1 0 0. By using this, we want to time the time diagram of by using a truth table. 2-bit counter circuit diagram. The diagram is a 2-bit up counter included two flip-flops connected into a common clock. As we see here, the two flip-flops can connected in the one clock. The flip-flop toggles are every clock pulse, while the second toggles to every pulses. This configuration generates the desired binary counting sequence 00 01 10 11, as we see in this two table 00 01 10 11. This is the initial state and this is a memory state. It is a reset set. It is a set. Um, Timing of for the 2-bit counter. The timing of a binary illustrate the uh, relationship between the clock signal and the counter outputs. Each transition in a clock signal corresponds to change in the output state of the counter. The visible of response representation helps to understand how the counter increments with each pulse. It shows the increment of the each pulse, how it will increasement as we seen in this diagram. Now we want to come to 3-bit synchronous up counter. The 3-bit synchronous up counter can count the 0 to 7 in binary number 0000 to 111. It comprises three flip-flops that are interconnected and ensures the synchronous operation. The addition of flip-flop allows for a great range of a binary counting appeared. Now we want to see the circuit diagram. The circuit diagram for the 3-bit counter features three flip-flops connected to a common clock signal. This output from the first two flip-flops determine the state of the third flip-flop for the toggling. The arrangement of allows for the expanded counting sequence of 00 0 0 1 and 1 0 1 and 1 1, as we see in this diagram. Time diagramming 3-bit up counter. The timing diagram for a 3-bit up counter shows the output states corresponding each clock pulse. It shows the output of each clock pulse. Each flip-flop changes the state based on the clock and the preceding flip-flops and outputs. It's preceding the flip-flops and outputs. This diagram illustrates the counting of sequence and timing relationships are crucial for the design of validation. Applications of synchronous up counter. Synchronous up counter is widely used in the digital system for counting events or pulses. These serve as a fundamental components in the frequency of a device and the digital local applications. This is a predictable behavior and synchronous nature make them reliable for the various digital circuits. Conclusion and future directions. Synchronous up counter of foundational in digital electronics, providing reliable counting mechanisms. Future advancements may be included more component multi-bit counters and integration with programmable logic. Understanding these counters is crucial for the engineers working in digital design and automation. Thank you.